7.3. Solving quadratic equations by graphing. The goal for this section is to solve quadratic equations by graphing the corresponding function. Let's take a look at an example. We're going to be using a TI-83 for these examples. If you want, you can also use Desmos, which is a free graphing calculator online. The only downside is you cannot bring Desmos into a departmental. Example 1. The flight time for a long-distance water ski jumper depends on the initial velocity of the jump and the angle of the ramp. For one particular jump, the ramp has a vertical height of 5 meters above water level. The height of the ski jumper in height h of t in meters over time t set in seconds can be modeled by the following function. H of t is equal to 5.0 plus 24.46 t minus 4.9 t squared. How long does this water ski jumper hold his flight pose? It says the skier holds his flight pose until he is 4 meters above the water. So the height is going to be 4 meters. So 4 is equal to 5.0 plus 24.46 t minus 4.9 t squared. If you substitute 4 in for h of t to get a quadratic equation, I can use this to determine the time when the skier's height above the water is 4 meters. We subtract 4 from both sides to get 0 is equal to 1 plus 24.46 t minus 4.9 t squared. Then we can use a graphing calculator or other technology to figure out what our roots are going to be. If I go to my graphing calculator, I hit y equals. I can then enter my equation as it is. I can say 1 plus 24.46x minus 4.9x squared. So I need to find where are my x-intercepts. On a TI-83, once you've entered this, you can just hit graph, and the function will graph for you. To find x-intercepts, you hit second, trace. Then you can go, we want to find the 0, so we're going to hit 2. You need to select your left bound, or someplace to the left of the 0. So I'm going to pick right there. And I'm going to hit enter. Our right bound will be somewhere to the right of the 0. I'm going to pick there, enter. Then I need to take my best guess at whereabouts it is. That's pretty close. So I'm going to hit enter. So my 0 then will be y is 5.3 times 10 to the negative 15. That is very, very close to 0. Perfect. So it's 0 where x is equal to negative 0.41-ish. And then I need to find my other x-intercept. So I'm going second, calc. I want to do a 0 again. So now I need somewhere to the left of my 0. Oh, there we go. That's to the left of my 0. I'm going to hit enter, and then I need to the right of my 0. Hit enter, and my best guess. That's pretty close. Hit enter. My 0 is at 5.032. So now let's take a look at this in the context of the problem. So I got my x-intercepts to be 5.032 and negative 0.041. If you reread the problem, you can figure out that one of these solutions doesn't really make sense. Time can't be negative, so we know that he's not going to hold his pose until negative 0.041 seconds. But 5 seconds does make sense. So let's make sure that the left side is equal to the right side if we put 5.032 in for our time. So if left side is 4.0, right side is 5.0 plus 24.46 times 5.032 minus 4.9 times 5.032 squared. If we plug this into our calculators, we'll find that 4.0 is equal to 4.0. So the left side is very, very close to equal to the right side. So the ski jumper holds his flight pose for about 5 seconds. Determine the roots of the quadratic equation, verify your answers. So I have this quadratic equation. If you notice, it isn't in standard form. that's okay. We can still find the roots. The roots can also be found if you have two quadratic equations. Sorry, if you have a quadratic equation but it's not in standard form, you can simply graph the left side and graph the right side, and then the intersections of those will be the roots. So if we go to my TI calculator, I'm going to put these equations into it. I went to my graphing calculator, I hit y equals, and I entered my left side and my right side of my quadratic equation. Then I hit graph. The solution will be the intersection points of these two parabolas. In order to find those, I need to go second, trace, and this time I want to find an intersection, so I'm going to hit 5. Now, my first curve is going to be my top curve. Yep, that looks good. My second curve will be my bottom curve, very close to the value. That looks good. And my best guess, wrong way, about there. Hit enter. It tells me the intersection is at 4.20, where y is equal to 3.008. Now I need to find my second intersection. I can do this the exact same way, and I will get my second intersection to be 2.380. Now I can verify that my left side is equal to the right side for both of these values of x. So for x equals 0.420, I can plug this back into my formula for x. 3 times 0.420 squared minus 6 times 0.420 plus 5 is equal to 3.009, whereas my right side is equal to 3.007. These are very, very, very close, so I know that my answer is correct. I can do the same thing for where x is equal to 2.380 and get again that they are very, very, very close. In summary, a quadratic equation can be solved by graphing the corresponding quadratic function. The standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. The roots are the x-intercepts of the graph of corresponding quadratic function. They are also the zeros of the corresponding quadratic function. You need to know that a quadratic equation is any second-degree equation that contains a polynomial in one variable. So if we have a squared plus 3a minus 4 is a quadratic equation. If a quadratic equation is in standard form, you can graph the corresponding quadratic function and determine the zeros of the function to solve the equation. If it's not in standard form, you can graph the left side and the right side as two different functions on the same axes. The x-coordinates of the points of the intersection of the two graphs are the roots of the equation. For any quadratic equation, there can be 0, 1, or 2 real roots. This is because a parabola can intersect the x-axis in 0, 1, or 2 places. So if we have a parabola that is below the x-axis and it's opening down, so our a value is going to be less than 0, then we'll have 0 roots. If we have a parabola where the vertex is on the x-axis, then we'll have 1 root. And if it is above, we will have 2.